Deep beneath the Earth's crust lies a power so immense that it has the potential to shape civilizations and redefine landscapes. Volcanoes, those majestic yet terrifying giants, are not merely mountains. They are pathways to the very heart of our planet, revealing the tumultuous activities of molten rock and gas. But what really makes volcanoes tick? How do they form, and why do some of them unleash their fury while others slumber peacefully for centuries? To understand volcanoes, we must first delve into the Earth's internal structure. The Earth is made up of several layers: the inner and outer core, the mantle, and the crust. The mantle, a thick layer of solid rock, is where the magic happens. The heat from the core causes this rock to melt into magma, which then rises through cracks and weaknesses in the crust. This process creates the volcanoes we see today, some of which could erupt with devastating consequences. Statistically, there are about 1,500 active volcanoes worldwide. An active volcano is one that has erupted within the last 10,000 years, but that number doesn't truly capture the risk. Supervolcanoes, a term that strikes fear into scientists and civilians alike, can erupt with a force that dwarfs regular volcanoes. Take the Yellowstone caldera, for example, located in Wyoming, USA. It has erupted 3 times in the past 2.1 million years, with the last eruption occurring about 640,000 years ago. Scientists estimate that should it erupt again, the impact could be cataclysmic, spewing ash across the United States and affecting global climate. The eruption of Mount Tambora in 1815 serves as a historical reminder of volcanic power. After its eruption, which killed tens of thousands of people, the ensuing ash emissions cooled the Earth's climate the following year, leading to what is now known as the year without a summer. Crops failed, food shortages ensued, and it led to widespread famine. Such events showcase the immediate human effects resulting from volcanic activity, making us question, how prepared are we for the next big eruption? But it's not just the massive eruptions we should be concerned about. Even smaller eruptions can have significant localized effects, wreaking havoc on communities and ecosystems. Volcanic eruptions are unpredictable, and even scientists with sophisticated equipment can only hope to predict them within a limited timeframe. As we delve deeper into this documentary, we will explore specific volcanoes with the power to change civilization forever. But first, it's crucial to recognize the intimate relationship between humans and volcanoes, where beauty and destruction coexist. What happens when that balance is tipped? This question will haunt us as we venture further into the heart of these giants. Supervolcanoes, a term that incites both wonder and fear. These geological giants are not merely larger versions of regular volcanoes, they are on a different scale entirely. A supervolcano has the capability to erupt with a force many times greater than that of ordinary volcanoes, potentially spewing ash and gas for thousands of miles. The Yellowstone caldera, again, serves as a prime example of this terrifying phenomenon, but it is not alone. In fact, scientists have identified several supervolcanoes around the world, each with its own history and potential for destruction. The Toba caldera in Indonesia, for instance, is infamous for its cataclysmic eruption approximately 74,000 years ago. This event is believed to have led to a volcanic winter, dropping global temperatures and dramatically reducing the human population at the time. The eruption is estimated to have been 1,000 times more powerful than Mount St. Helens, reshaping the landscape and leaving behind a caldera that measures 100 kilometers across. Such a cataclysmic event raises questions about the Earth's resilience and the limits of human adaptability. But what exactly generates such immense power within a supervolcano? The answer lies in the magma chamber, a vast reservoir of molten rock beneath the surface. Unlike ordinary volcanoes that may have a side vent, supervolcanoes typically erupt from a collapsed caldera or during a large eruption cycle. The buildup of pressure in these chambers is so great that, when released, the consequences are felt globally. Another prominent example of supervolcanic activity is the Campi Flegrei in Italy. This supervolcano is directly beneath the city of Naples and poses a significant risk to millions of people. The last major eruption occurred nearly 40,000 years ago, but scientists warn that activity in the area is still ongoing. Studies show that the ground continues to rise and fall, indicating potential movement of magma below. This geological activity raises alarms, especially since a large eruption could lead to catastrophic consequences not only for Italy but also for the wider European region. The difference between a regular volcano and a supervolcano can be likened to comparing firecrackers to nuclear bombs. The sheer scale of destruction and the long-term effects of a supervolcanic eruption can alter the planet's climate, agriculture, and even biodiversity. The term volcanic winter has been coined to describe the chilling effects that follow an eruption, a term that reminds us of Toba and its catastrophic aftermath. As we explore these powerful geological features, the reality becomes clear: supervolcanoes are not just natural wonders, they are ticking time bombs waiting for the right moment to explode. How will humanity respond when that moment arrives? Will we be prepared to face the aftermath of nature's fury? History is riddled with stories of catastrophic volcanic eruptions that have changed the course of human civilization. From Pompeii to Santorini, these events not only claimed lives but also reshaped societies, economies, and cultures. Let's take a closer look at some of the most significant eruptions in history and their long-lasting effects. The eruption of Mount Vesuvius in 79 AD is perhaps one of the most famous volcanic events. This catastrophic eruption buried the Roman cities of Pompeii and Herculaneum under a thick blanket of ash, preserving them for centuries. Thousands lost their lives, and the subsequent ash fallout created a climate anomaly that affected agriculture in the region for years to come. The complete loss of the vibrant Roman community serves as a chilling reminder of nature's wrath. Fast forward to 1600, and we encounter the eruption of Mount Huayna in Peru, which is often overlooked but had devastating consequences. This eruption was the largest in South America's recorded history, leading to a tectonic shift in agricultural practices and economic downturns. The massive ash cloud disrupted weather patterns, leading to crop failures that ultimately contributed to societal instability and unrest. This eruption is believed to have triggered a series of revolts and changes in leadership as food scarcity led desperate populations to seek change. Understanding the social ramifications of these eruptions reveals that they can trigger more than just immediate destruction; they can alter the very fabric of society. Another key example is the eruption of Krakatoa in 1883. The explosion was so violent it was heard over 3,000 miles away, killing tens of thousands of people due to tsunamis and ash fallout. The eruption caused global temperatures to drop, leading to abnormal weather patterns for years. Its effects were felt not just locally but around the globe, proving that volcanic eruptions can disrupt the climate on an international scale. When we examine these past eruptions, we see a pattern: volcanic activity does not merely shake the ground, it shakes the foundations of civilization itself. The fragile balance that humanity has with nature often tips, leading to profound and unsettling changes in society. As we continue to explore the potential threats posed by volcanoes, we must consider not just the physical destruction but also the socio-political upheaval that follows. How would modern civilization cope in the face of such an eruption? Would our interconnected world respond more efficiently, or would we find ourselves unprepared for the catastrophic consequences? It's a question that looms large as we review the destructive potential of nature's fury. Predicting volcanic eruptions has long been a challenge for scientists. Despite advancements in technology and understanding of geological processes, the complete unpredictability of when a volcano might erupt remains a haunting reality. Understanding the signs that a volcano is awakening is crucial for mitigating disasters and saving lives. One of the primary methods scientists use to predict volcanic activity is through monitoring seismic activity. Earthquakes can often signal the movement of magma beneath a volcano, indicating that an eruption may be imminent. For instance, the 1980 eruption of Mount St. Helens in Washington state was preceded by a series of earthquakes, allowing scientists to issue warnings that saved countless lives. However, not all eruptions come with clear warning signs, and some, like the eruption of Mount Pinatubo in 1991, surprised scientists with their intensity and timing. Gas emissions are another critical aspect of understanding volcanic activity. As magma rises, it releases gases like sulfur dioxide and carbon dioxide. An increase in these gases can indicate that an eruption is approaching. In some cases, monitoring changes in water temperature and chemistry in nearby lakes can also provide insights into a volcano's behavior. In recent years, scientists have begun utilizing satellite technology to monitor ground deformation. These methods allow for a more comprehensive understanding of how a volcano is changing shape, giving scientists important clues as to its state. However, the unpredictability remains a double-edged sword. While technology has improved our understanding, there is still a vast gap between knowledge and action. The 1991 eruption of Mount Pinatubo serves as a case study of both success and failure in predictive measures. While scientists were able to provide warnings, many residents were reluctant to leave their homes, fearing it was an overreaction. This highlights the communication gap that often exists between scientists and the general public. As a result, even with the correct predictions, human behavior can compound the risks. As we delve into the challenges of eruption prediction, we must also consider the human element. How can we bridge the gap between scientific understanding and community readiness? The efficacy of communication and preparedness protocols in the face of geological threats is a paramount concern as we prepare for the unpredictable future of volcanic eruptions. As we explore the volcanic threats that loom over humanity, one undeniable truth emerges: preparation is key. In a world where nature wields such immense power, communities must take proactive measures to ensure their safety. But how can societies effectively prepare for volcanic eruptions that may come without warning? Historically, the consequences of volcanic eruptions have often been catastrophic, yet they also provide invaluable lessons for the future. The disaster response following the 2010 eruption of geological in Iceland offers insights into both the challenges and successes of volcanic emergency management. This eruption caused widespread air travel disruptions across Europe, stranding millions of passengers. Although the immediate threat was primarily aviation-related, the incident highlighted the interconnectedness of global infrastructure and how quickly a local event can escalate into a worldwide crisis. Education and awareness campaigns play crucial roles in preparing communities in high-risk volcanic zones. Schools and organizations must educate citizens about the risks and establish evacuation routes, emergency protocols, and communication plans. This leads us to a fundamental question: how prepared is your community? The challenge lies not simply in preparation but in fostering a culture of readiness. For instance, in places like Japan, residents are accustomed to regular earthquake drills and disaster preparedness training. This ingrained culture of preparedness fosters resilience when disaster strikes, enabling societies to adapt quickly and effectively in times of crisis. In contrast, regions with less awareness or less frequent natural disasters may struggle with complacency. This complacency can lead to catastrophic outcomes when faced with volcanic eruptions. How can we cultivate a culture of preparedness? And is it possible for regions that have historically been less affected by such disasters? Looking forward, it becomes essential to invest in scientific research that addresses the gaps in eruption prediction and response. Collaborative efforts among governments, scientists, and communities can lead to improved early warning systems and better education on the risks associated with volcanism. As we conclude this exploration of volcanic threats, we are left with a haunting realization: the Earth is alive, and its unpredictable nature is both terrifying and awe-inspiring. The question remains, how will we prepare, respond, and ultimately survive the next volcanic eruption that could change our civilization forever? With knowledge comes responsibility, and the future is ours to shape. As we look back through the annals of history, we find countless accounts of volcanic eruptions that have shaped civilizations, leaving indelible marks on human culture, economy, and ecology. One such example is the eruption of Mount Vesuvius in 79 AD, a tragedy etched into the fabric of Roman history. The ancient city of Pompeii was buried under a thick blanket of volcanic ash, preserving it for centuries but also demonstrating the ferocity of nature's wrath. Archaeological studies reveal that the eruption released approximately 1.5 million metric tons of ash into the atmosphere every second, creating a deadly cloud that engulfed the city and its inhabitants. As we explore these forgotten stories, let's consider the lessons they impart about the interplay between humans and volcanoes, a relationship marked by awe and trepidation. Let's turn our attention to Indonesia, where the eruption of Krakatoa in 1883 not only obliterated an island but significantly affected global climate patterns, demonstrating the far-reaching consequences of volcanic activity. The eruption was accompanied by tsunamis, killing over 36,000 people and creating atmospheric shock waves heard over 3,000 miles away. What makes the Krakatoa eruption particularly fascinating is that it altered the world's climate for years, with recorded temperature drops and stunning sunsets caused by the ash ejected high into the atmosphere. In the aftermath, agriculture suffered. Crops failed not only in Indonesia but as far away as the United States. These instances remind us that volcanic eruptions can extend their impacts far beyond local devastation, transforming climates and threatening food security on a global scale. The eruption of Tambora in 1815, the most powerful eruption in recorded history, caused what became known as the Year Without a Summer in 1816. Crop failures during this time contributed to food shortages and social unrest across the Northern Hemisphere. This eruption serves as a poignant reminder that nature can disrupt not just local communities but entire civilizations. However, understanding our past is not just about recounting tragedies. It's also about recognizing patterns and preparing for the future. By analyzing past eruptions, scientists have developed models to predict potential volcanic activity and its impacts. For instance, researchers have created simulations of how the ash from potential future eruptions might spread, leading to improved evacuation plans and resource management strategies. The catastrophic effects of volcanic eruptions should inspire proactive measures, strengthening our ability to respond to future threats, while ensuring the survival of future generations. Now, let's shift our gaze to a more recent example of how volcanic activity can disrupt modern life: the 2010 eruption of geological in Iceland. This volcanic event sent ash clouds across Europe, causing the cancellation of over 100,000 flights and stranding millions of travelers. This incident serves as a stark reminder of how interconnected our modern world is, and how quickly an eruption can ripple through our global economy with staggering effects on travel, trade, and daily life. As we reflect on these forgotten eruptions, we must ask ourselves, are we learning from history or merely repeating it? With the increasing potential for volcanic activity due to climate change, understanding and preparing for these disasters has never been more critical. What lessons will we carry forward to ensure that civilization stands resilient in the face of nature's fury? The answer lies not just in science, but in our collective memory and willingness to adapt, and the clock is ticking. Moving forward, the integration of cutting-edge technology with traditional geological research is shaping the future of volcano monitoring. Today, scientists utilize a combination of satellite imagery, geophysical data, and advanced computer modeling to identify potential volcanic threats before they escalate. This interplay between old-world science and high-tech innovation is pivotal in our quest to decipher the enigmatic behavior of volcanoes. For example, satellite radar interferometry allows scientists to monitor ground deformation, which often occurs prior to volcanic eruptions. When magma forces its way up through the Earth's crust, the land above it can swell. By detecting these physical changes, researchers can issue warnings to surrounding communities. Furthermore, remote sensing technologies help analyze gas emissions that can indicate imminent eruptions. These breakthroughs provide crucial time to evacuate populations and mitigate the potential for disaster. An innovative approach is utilizing drones equipped with sensors to gather data in real time during volcanic eruptions. Their ability to navigate hazardous environments allows for unprecedented access to volcanoes and the collection of vital information about gas emissions, ash dispersal, and thermal activity. This data is essential for improving models that predict eruption behavior and aid in developing effective response strategies. However, technology alone is not enough. The relationship between scientists and local communities plays an equally important role in disaster preparedness. Raising awareness and educating citizens about volcanic risks can significantly improve outcomes during an eruption. Programs that engage communities in monitoring efforts and create clear communication channels between scientists and residents have demonstrated success in regions prone to volcanic activity. Take the case of Mount Merapi in Indonesia. Scientists have established a comprehensive monitoring system that includes community involvement. Local residents work alongside experts, sharing observations and participating in evacuation drills. This collaboration ensures that when warnings are issued, communities are prepared to act swiftly, protecting lives and minimizing losses. As we look to the future, the potential for artificial intelligence and machine learning to revolutionize volcanic research is becoming more apparent. These technologies can analyze vast datasets from historical eruptions and current monitoring systems to uncover patterns that human analysis might overlook. By predicting potential eruption scenarios, AI can significantly enhance the effectiveness of early warning systems and disaster preparedness strategies. But even with these advancements, the question remains, are we ready to face the volcanic threats that loom in our future? The intersection between technology, community, and proactive measures will ultimately determine our ability to thwart such catastrophic events. What lies ahead is not just the evolution of science but a collective responsibility to safeguard our civilizations from nature's most formidable forces. As we embrace these innovations, we must also remain humble, acknowledging that despite our advancements, the Earth still holds many secrets. The challenge is not just to better understand these titanic forces but to coexist with them, an intricate dance of resilience and respect that will define our future. Imagine a cataclysmic eruption from one of the world's supervolcanoes, like Yellowstone or Toba. The societal impact would be staggering, far beyond what we can currently comprehend. Such an event would likely lead to widespread panic, mass evacuations, and a scramble for resources. The ramifications would ripple through every facet of modern life, economies would crumble, food supplies would dwindle, and the social fabric of nations could fray under the pressure of survival. Scientists estimate that a sufficiently powerful eruption could eject enough ash and gases into the atmosphere to disrupt global weather patterns, leading to years of climatic instability. This situation could trigger a cascade of events, including food shortages across continents due to failed harvests. Nations would face the daunting task of addressing mass migration as people flee affected areas, igniting potential conflicts over dwindling resources. The psychological impact on those affected would be profound as well. Studies have shown that natural disasters can lead to long-term mental health issues, including anxiety, depression, and post-traumatic stress disorder. The grief and trauma associated with losing homes, loved ones, and the familiar patterns of daily life can leave scars that last generations. As we consider the implications of such a catastrophe, we must address not just the immediate response but the long-term recovery and healing required to rebuild lives. Moreover, the economic ramifications of a major eruption would be staggering. A report by the National Park Service highlights that a significant eruption at Yellowstone could result in tens of billions of dollars in damages and take decades for the local economy to recover. Moreover, transport and trade routes would be crippled, affecting global supply chains. The interdependence of modern economies means that the impact of such an eruption would not be confined to the immediate region but would resonate worldwide. Consider the tourism industry, particularly in regions that thrive on their natural beauty and geological wonders. The economic boost provided by visitors to volcanic areas could disappear overnight, leaving communities struggling to find alternative sources of income. Similarly, agricultural sectors reliant on stable climates would be devastated, leading to food price spikes and scarcity. What's more alarming is the potential for societal divides to deepen in the wake of a volcanic catastrophe. As resources become scarce, communities may turn against each other. The fabric of solidarity could unravel as desperation sets in, leading to increased crime and social unrest, a reality we cannot afford to ignore. The evidence from past eruptions suggests that the key to resilience lies in preparedness and cooperation. Societies that cultivate strong support systems and foster a culture of collaboration may weather such storms better than those that remain isolated. As we contemplate the potential future, the question remains, are we doing enough to prepare for such eventualities? In a world already facing significant environmental challenges, addressing the threat of volcanic eruptions has become more crucial than ever. As we stand on the brink of uncertainty, will we heed the warnings of history and take proactive steps to ensure the survival of our societies? It is a shared responsibility, one that requires foresight, compassion, and above all, a commitment to safeguarding our future, a future that might very well hinge on our response to nature's most powerful forces. In the wake of disasters, humanity often reveals its greatest strength, resilience. The indomitable spirit of survival shines through as communities band together to support one another amidst wreckage and despair. Volcanic eruptions, while devastating, have also unveiled remarkable stories of human determination and solidarity. Consider the tales from Mount St. Helens, where a devastating eruption in 1980 resulted in the loss of life, homes, and livelihoods. Yet, in the aftermath, local communities showed immense grit, rebuilding not only their physical environment but also their sense of identity and purpose. This regenerative spirit is often seen in affected regions as populations come together, pooling resources to recover and foster growth. In Indonesia, where volcanic activity is frequent, the stories of resilience are even more profound. After the eruption of Merapi in 2010, communities did not just reconstruct, they innovated. Local farmers began implementing sustainable agricultural practices, using volcanic ash to enrich the soil while simultaneously diversifying their crops. This adaptability illustrates that even amidst destruction, opportunities for growth can arise. The ability to pivot and learn from adversity is a hallmark of the human experience, vital for navigating any catastrophic event. Moreover, as technology advances, we see how innovative solutions can empower communities to withstand future eruptions. Initiatives utilizing technology for local monitoring, early warning systems, and community engagement are becoming increasingly popular. In areas like Japan, where volcanoes frequently threaten life, public awareness campaigns educate citizens on proper evacuation procedures and emergency preparedness. This proactive mindset encourages resilience by fostering knowledge and preparedness that can save lives. The art of storytelling, too, plays a pivotal role in resilience. Sharing experiences and knowledge about past volcanic eruptions fosters a culture of remembrance. Through narrative, communities can not only honor those lost but also reinforce lessons learned. This collective memory forms a robust foundation for future generations, teaching the importance of readiness and community support. As we look ahead, we must recognize that embracing our vulnerabilities is key to building resilience. Acknowledging that threats loom on the horizon can empower societies to take actionable steps in safeguarding their future. Ultimately, as we navigate through these complexities, we must ask ourselves, how do we define progress in the face of potential calamity? Resilience is not merely about rebuilding, it is about transforming the very foundations upon which we stand, creating networks of support, and nurturing a culture that prioritizes collective well-being amidst uncertainty. The spirit of survival is contagious. It inspires hope and renewed purpose when faced with seemingly insurmountable odds. As we conclude our exploration of volcanoes that could end civilization, let us hold on to these stories of resilience. In their shadows, we find the strength to rise, adapt, and thrive. As we wrap up this exploration of volcanoes that could end civilization, we are left with profound questions about our relationship with nature. How do we coexist with these powerful forces that can shape our world in both beautiful and catastrophic ways? As we examine the past, present, and potential future, one thing becomes clear. The legacy we leave behind is intricately linked to our understanding of, and respect for, volcanic forces. Consider the lessons of our history. From Vesuvius to Krakatoa, civilizations have risen and fallen in the wake of volcanic activity. Each eruption has taught us something about the fragility of our existence and the necessity of preparedness. Yet, every eruption also serves as a call to action, urging us to strengthen our resilience in the face of nature's unpredictable might. It is through this awareness that we can build societies that are not only informed but also empowered to respond effectively when nature unleashes its fury. As we reflect on the potential repercussions of a major eruption, it's essential to recognize that our fate does not rest solely in the hands of science. While technological advancements promise to bolster our defenses, the heart of our resilience lies within our communities. The collaborative efforts that foster strong relationships and shared knowledge will likely be our greatest asset as we face these potential threats. From local grassroots initiatives to global collaborations, it is evident that our journey forward must be collective. Furthermore, our legacy is intertwined with our environment. Respecting the delicate balance of nature and understanding our role within it can guide us toward a sustainable future. Each choice we make today can influence the stability of our world tomorrow. Whether through education, sustainable development, or community engagement, the steps we take now will echo through generations. In conclusion, as we navigate the complexities of living in a world with potential volcanic threats, we do so with the knowledge that we are not alone. Our resilience is built on a foundation of shared experiences, a community's collective spirit, and an unwavering commitment to safeguarding our civilization. Together, we can transform the narrative around volcanoes into one of hope, strength, and preparedness. Let us honor the lessons of the past and embrace the opportunities of the future, nurturing a legacy that transcends the challenges we face today. As we stand at the crossroads of uncertainty, will we rise to meet the challenges ahead? The answer lies within us, waiting to be discovered. Imagine living in a city adorned with beautiful architecture, a vibrant culture, and rich history. Now imagine that nestled beneath the surface is a sleeping giant, one that has the potential to change your life forever. This scenario is not just a distant nightmare but a looming reality for millions around the world. In this chapter, we will delve into the major urban centers that lie perilously close to active volcanoes, examining their unique vulnerabilities and the historical precedents that highlight the potential for catastrophic eruptions. Consider Naples, Italy, a city with a population of nearly 1 million, situated just a stone's throw from the infamous Mount Vesuvius. This volcano has a notorious history, famously erupting in 79 AD and burying the cities of Pompeii and Herculaneum beneath layers of ash and pumice. Recent studies show that Vesuvius is overdue for an eruption, with some estimates suggesting that an eruption could occur within the next few decades. The Italian government has prepared emergency plans, yet the risk remains significantly high due to the dense population. Reports indicate that if Vesuvius erupts, the consequences could be catastrophic, leading to thousands of casualties and massive economic losses. Similarly, in Indonesia, the capital city of Jakarta sits close to several active volcanoes, including the towering Mount Merapi. This volcano is one of the most active in the world, with a history of explosive eruptions that have claimed lives and disrupted societies. Just in 2010, a series of eruptions resulted in 347 deaths and forced the evacuation of thousands. The Indonesian government has been criticized for its inadequate disaster preparedness, particularly in the urban areas where the population density grows. Next, let's turn our eyes to Mexico City, a sprawling metropolis home to over 9 million people, situated close to nearly 24 volcanoes. Most notably, it's only about 50 kilometers away from Popocatépetl, one of Mexico's most active volcanoes. The 1994 eruption sent plumes of ash towering into the sky, disrupting air travel and causing widespread fear among citizens. The Mexican government has since established alert systems and evacuation plans, but the urban layout and density pose major challenges for rapid evacuations. These cities serve as stark reminders of the potential for volcanic disasters. They are not just historical tales but live examples of how civilization dances on the precipice of nature's most powerful forces. What can be done to mitigate the risks associated with living in these volcanic shadows? As we explore the measures taken and the challenges faced by these urban centers, we uncover the balance between living with beauty and the threat that lies just beneath. What makes these cities different from others? Is it just their geographical disadvantage, or is there something deeper that puts them at risk? We'll analyze the policies and education efforts as we continue to navigate the thin line between marvel and disaster. The very fabric of our planet is changing, and lurking beneath the surface are forces that could be triggered by our actions. In this chapter, we will explore the relationship between climate change and volcanic activity, and how the warming planet impacts the volatility of these geological titans. Research has shown that climate change can significantly influence volcanic eruptions. As global temperatures rise, glaciers retreat and the weight on the Earth's crust lessens, allowing magma chambers to expand. This phenomenon has been observed in Iceland, where the melting of glaciers has been linked to increased volcanic activity. Studies indicate that eruptions driven by climate-induced stress on the crust could occur more frequently as our planet continues to warm. Additionally, the interaction between volcanic eruptions and climate change creates a vicious cycle. For example, when a large volcano erupts, it can release massive amounts of ash and sulfur dioxide into the atmosphere, affecting global temperatures and leading to temporary cooling. The 1815 eruption of Mount Tambora in Indonesia is a prime example. It resulted in what became known as the year without a summer, causing widespread famine across the northern hemisphere. As our climate continues to change, we must consider how future volcanic eruptions could further exacerbate existing climate issues. The potential for major eruptions leading to significant climate effects adds another layer of complexity to the already challenging issue of global warming. But it's not just the eruptions themselves that pose a threat. The increase in volcanic gas emissions due to climate change can significantly impact air quality and public health. The rise of smog and acid rain resulting from these gases poses challenges for governments and health organizations globally. In addition, studies suggest that populations in volcanic regions may see increased respiratory problems and other health issues as volcanic gas concentrations rise. The melting of ice caps and glaciers also raises concerns about lahars, destructive mudflows that occur when volcanic ash interacts with water. As temperatures rise and glaciers melt, these lahars can become more frequent and deadly. In 1985, the Nevado del Ruiz eruption in Colombia triggered a lahar that buried the town of Armero, resulting in over 20,000 deaths. What does this mean for our future? As we examine the interplay between climate change and volcanic activity, we realize the need for comprehensive global strategies to address both issues. Can we mitigate the impacts of climate change on volcanic activity and, in turn, prepare ourselves for the eruptions that may arise? The urgent questions drive us toward a crucial understanding of our planet's systems and our role in them. Volcanic tourism is a phenomenon that has grown exponentially over the years, allowing adventurers and nature enthusiasts to explore the very sites of destruction. It's a strange dynamic. We are both enchanted and terrified by these natural wonders. In this chapter, we will explore the rise of volcanic tourism, the economic impacts, and the potential dangers that come along with this booming industry. Countries like Iceland, Italy, and Indonesia have embraced volcanic tourism as a means of boosting their economies. Visitors flock to witness the raw power of eruptions, hike the craters, and marvel at breathtaking lava formations. In Iceland, the Fagradalsfjall eruption of 2021 drew thousands of tourists eager to see the spectacle of nature in real time. However, this influx of visitors also poses significant risks. The increased foot traffic can lead to environmental degradation and strain on local resources. Moreover, the thrill of volcanism can lead to reckless behavior among tourists. In 2022, a group of tourists in Italy ignored safety warnings and ventured too close to the crater of Mount Etna, leading to a dramatic helicopter rescue. These incidents raise crucial questions about the role of regulations and safety measures in volcanic tourism. While the economic benefits are undeniable, they must be weighed against the inherent risks associated with being in close proximity to active volcanoes. Volcanoes are unpredictable and can change behavior in an instant, a fact that is often forgotten by thrill-seeking tourists. In 1991, the catastrophic eruption of Mount Pinatubo in the Philippines led to the evacuation of thousands, and yet, just months before, the area was a popular site for trekkers and outdoor enthusiasts. Tour operators and local governments must strike a balance between promoting tourism and ensuring public safety. This involves implementing strict guidelines, educating visitors on the dangers, and developing emergency response plans. The tourism industry must also confront its environmental impact by ensuring that activities are sustainable and respectful to the natural surroundings. As we delve into the world of volcanic tourism, we must recognize both the allure of these natural wonders and the responsibility that comes with exploring them. The thrill of visiting an active volcano can transform lives, offering unique experiences, but as we open up these sites to tourism, are we also opening the door to potential disaster? It's a question worth pondering as we navigate the complexities of adventure and safety. When we think of volcanoes, many of us envision explosive eruptions, fiery lava flows, and clouds of ash filling the skies. However, what if I told you that their impact stretches far beyond the immediate vicinity? Volcanoes hold a profound connection to our global climate system, influencing weather patterns and even contributing to mass extinction events throughout Earth's history. In this chapter, we will delve deep into the interlinked dynamics of volcanic activity and climate change, exploring how eruptions alter atmospheric conditions and what this means for humankind. Volcanic eruptions inject massive amounts of sulfur dioxide into the stratosphere. This gas transforms into tiny sulfuric acid droplets that reflect sunlight away from the Earth, leading to temporary cooling effects. One notable example is the eruption of Mount Pinatubo in 1991. This eruption released more than 20 million tons of sulfur dioxide, which resulted in global temperatures dropping by about 0.5 degrees Celsius for nearly 2 years. Such cooling can lead to significant agricultural impacts, affecting food supply chains worldwide. Throughout history, the relationship between eruptions and climate has played a critical role. The eruption of Toba, approximately 74,000 years ago, is believed to have caused a volcanic winter that drastically reduced human populations, creating what some scientists refer to as a bottleneck in human evolution. The resulting climatic upheavals had catastrophic effects on flora and fauna, leading to widespread extinctions. As our climate continues to warm due to human activity, the potential for interaction with volcanic phenomena remains an area of concern. Increased temperatures could lead to glacial melting, subsequently resulting in increased volcanic activity as the pressure on magma chambers is relieved. This phenomenon is referred to as glacial isostatic adjustment. The volcanoes in Iceland and Alaska, for instance, are already experiencing the effects of climate change due to this phenomenon, resulting in increased eruptions and unpredictable behavior. Furthermore, looking forward, we must consider the potential for future eruptions to exacerbate climate change itself. Major volcanic eruptions can inject significant amounts of carbon dioxide into the atmosphere, furthering the greenhouse effect. One major eruption can disrupt climate equilibrium for decades, posing threats not just locally but also globally. As we continue to navigate the complexities of global warming, the need to monitor volcanic activity in conjunction with climate patterns becomes increasingly vital. In conclusion, the relationship between volcanoes and climate change is both intricate and interdependent. Recognizing this connection allows us to better prepare for future volcanic events that could exacerbate climate challenges we already face. History has shown us the immense power of volcanoes, and as we look to the future, we must remain vigilant and informed of how these natural wonders can alter our world. But what happens when humans play a role in the volcanic cycle? Stay tuned as we explore the next chapter, where we dive into the impacts of human activity on volcanic systems and the potential repercussions for our civilization. As we continue our exploration into the world of volcanoes, it's crucial to understand that humankind is intricately connected with these geological giants in ways we often overlook. From our actions that may lead to increased volcanic activity to how we adapt our lives around these formidable forces, it's a multifaceted relationship marked by both challenges and innovations. In this chapter, we will dive into the human role in activating sleeping giants, the effects of geothermal energy projects, and the delicate balance between harnessing nature's power and respecting its limits. While it might seem distant, the pressures we exert on the Earth's crust can influence volcanic activity. Fracking, mining, groundwater extraction, and even large-scale construction projects can add stress to the geological structures that hold magma beneath the surface. An example of this can be seen in the events surrounding the 2010 eruption of geological in Iceland. As drilling and geothermal projects expanded in the region, they altered the already fragile equilibrium of the volcano, resulting in a dramatic eruption that disrupted air travel across Europe and caused widespread economic repercussions. Geothermal energy projects are one of the clearest intersections of human innovation and volcanic systems. Harnessing the heat generated by volcanoes for energy production can provide renewable and sustainable energy sources for millions. However, the caveat lies in how these projects are constructed and managed. Over-extraction of geothermal resources can lead to instability in volcanic regions, which in some cases have triggered eruptions or created hazardous conditions. The case of the geothermal facility in the Azores serves as a cautionary tale, reminding us of the fine line we walk when tapping into nature's power. Moreover, consider urban planning in volcanic regions. Millions of people live in the shadow of volcanoes, from Naples near Mount Vesuvius to the entire island of Hawaii. The desire for beautiful landscapes and fertile soil leads to thriving populations, but it also places these communities at risk. The challenge lies in balancing the benefits of living close to geological wonders with the threats they pose. Disaster preparedness is key, yet many communities remain underprepared for a potential eruption. As we approach the potential for future eruptions, the question remains, how can we responsibly coexist with these powerful forces of nature? The key is integrated risk management and early warning systems that combine scientific data and community engagement. By creating local emergency response plans and investing in monitoring technologies, we can mitigate the effects of volcanic eruptions on communities and the environment. In summary, humanity's role in activating and managing volcanic systems is complex. It is a relationship that requires respect, understanding, and preparation. As we stand on the brink of potential future eruptions, the conversation must shift towards sustainability and coexistence. But what happens when these volcanoes erupt and the world is unprepared? In the next chapter, we will explore real-world case studies of volcanic eruptions in the modern era and the consequences that ensued. The 21st century has seen its fair share of volcanic eruptions that have left an indelible mark on societies. These events not only serve as stark reminders of nature's power but also offer us invaluable lessons about preparedness, response, and recovery. In this chapter, we will analyze some of the most significant volcanic eruptions of modern times, evaluating their impacts on communities, economies, and global systems. Let's turn our attention first to the eruption of Mount Merapi in Indonesia, which in 2010 erupted violently, displacing over 350,000 people and killing over 300. Merapi is known for its explosive eruptions, and the 2010 incident was no exception, with pyroclastic flows and ash columns reaching several kilometers into the atmosphere. Indonesia's Disaster Mitigation Agency played a crucial role in monitoring activities and implementing evacuation plans, yet the enormity of the eruption still caught many off guard. The consequences of such eruptions extend beyond immediate loss of life. The 2010 eruption disrupted air travel and economic trade routes, demonstrating how an eruption in one part of the world can ripple through global systems. Airlines faced massive losses, and countries reliant on tourism were severely impacted. The lesson learned here emphasizes the importance of international cooperation in devising emergency response protocols that consider global interconnectedness. Another recent eruption worth examining is the 2018 eruption of Kilauea in Hawaii, which unleashed lava flows that destroyed over 700 homes and caused significant structural damage. What makes Kilauea's eruption particularly noteworthy is not only its destructiveness but also its long-term implications on local infrastructure and ecosystems. Communities are left to grapple with recovery, rebuilding, and reimagining their futures in the wake of such devastation. As we evaluate these modern eruptions, we must also recognize the power of technology in monitoring and predicting volcanic behavior. Continuous advancements in satellite imaging, remote sensing, and ground-based instruments allow scientists to gather vital data and enhance our understanding of eruption precursors. This information is crucial for timely evacuation and disaster response. However, the reliance on technology also presents its challenges. The 2019 eruption of White Island in New Zealand highlighted the inherent risks involved in volcanic tourism. An unanticipated eruption claimed the lives of 22 people, raising questions about the safety protocols in place for those venturing into active volcanic sites. The tragedy underscores the need for stringent safety regulations and responsible tourism practices that prioritize human life over profit. As we reflect on these events, we must ask ourselves, are we adequately prepared for future volcanic threats? The realities of these modern eruptions provide sobering insights into our vulnerabilities. Our ability to learn from the past, adapt, and create robust systems will determine how we respond to future challenges posed by these extraordinary forces of nature. What insights can we glean from these case studies, and how can they shape our strategies as we move forward? Stay tuned for our next chapter where we will discuss the role of community resilience in the face of natural disasters. Supervolcanoes are not just massive eruptions, they are geological phenomena characterized by their colossal magma chambers and unique structures. These volcanoes, such as Yellowstone in the United States, have the potential to reshape entire landscapes and impact global climate. The average person understands volcanoes primarily as mountains that erupt with lava and ash. However, a supervolcano operates differently, hiding its immense power beneath the surface. To understand the anatomy of a supervolcano, let's look at the structure. At the core lies a magma chamber, which can extend several kilometers deep. This chamber can accumulate thousands of cubic kilometers of magma. What sets supervolcanoes apart is that they can erupt not just lava but also a vast amount of volcanic ash and gases, which can lead to devastating consequences. Historically, the eruptions of supervolcanoes have been catastrophic. One profound example is the eruption of the Toba supervolcano in Indonesia around 74,000 years ago. It is estimated to have released around 2,800 cubic kilometers of volcanic material, leading to a volcanic winter that lasted for years and drastically reduced the human population of that era. This event profoundly changed the course of human evolution, causing genetic bottlenecks that we can still trace today. Another key feature of supervolcanoes is their calderas. After an eruption, the ground often collapses into the emptied magma chamber, creating a caldera that can be several kilometers in diameter. The Yellowstone caldera itself is a prime example, roughly 30 miles long. Observing these calderas provides insights into the past behavior of these volcanoes and potential future activity. Research shows that supervolcanoes can also influence global climate patterns. The ash and gas emissions can lead to cooling effects, disrupting weather patterns worldwide. For instance, the eruption of Mount Pinatubo in 1991 caused a global temperature drop of about 0.5 degrees Celsius for a few years. Imagine the potential climate disruptions caused by a supervolcano eruption, which can be orders of magnitude larger. The stakes are undeniably high. Scientists are increasingly focused on determining the activity levels of supervolcanoes, especially Yellowstone. Monitoring efforts include ground deformation measurements, seismic activity tracking, and gas emissions analysis. Yet, the unpredictable nature of these volcanoes leaves many unanswered questions about when they might erupt next. As we delve further into understanding these titans of geology, it becomes evident that we must prepare emotionally, physically, and scientifically for a potential future that includes supervolcanic activity. In the next chapter, we will explore the current state of volcanic monitoring and the advanced technologies we have at our disposal to predict eruptions, and how effective they are in mitigating the risks involved. Throughout history, civilizations have risen and fallen under the shadow of volcanic activity. The relationship between humans and volcanoes is complex. They provide fertile soils for agriculture but also pose existential threats. The story of ancient Pompeii serves as a potent reminder of this duality. In 79 AD, the city of Pompeii was buried under a thick blanket of ash and pumice from the eruption of Mount Vesuvius. However, this eruption was not just an isolated event, it was a culmination of volcanic activity that had been ongoing for centuries. Archaeological evidence suggests that Pompeii was a bustling city, thriving due to its ideal location and proximity to rich trade routes. But Vesuvius was a ticking time bomb, and the residents had little awareness of the danger looming above them. Following the eruption, the city remained hidden for nearly 1,700 years until its rediscovery in the 18th century. The preservation of Pompeii provides a unique window into Roman life, complete with homes, marketplaces, and artworks. In stark contrast, the records of the eruption and the subsequent destruction tell a chilling tale of negligence and ignorance regarding natural disasters. The Roman citizens were completely unprepared for the catastrophic event that unfolded. As we reflect on this moment in history, several questions arise. How could such a vibrant civilization have been so oblivious to the power of nature? And what lessons can modern society learn from this tragedy? Another significant event is the eruption of the Santorini volcano around 1600 BC, which is believed to have contributed to the decline of the Minoan civilization. The ensuing tsunamis and ash clouds devastated the region, leading to agricultural collapses and societal changes. Further examples include the eruption of Mount Tambora in 1815, which caused what is referred to as the. As we forge ahead into the future, the field of volcanology is rapidly evolving, driven by technological advancements and innovative research methodologies. In a world where supervolcanoes and dangerous eruptions remain latent threats, understanding how scientists are working to predict and mitigate these risks has never been more critical.